Welcome to Tech with Kaushik. This is part 5 of our complete practice question series for the AIF-C01 AWS Certified AI Practitioner exam. Choose your answer before the timer ends, then review the correct answer, explanation, and exam tip. Let us begin part 5. Now tackle question number 116. We are now working with code generation. A developer gives a large language model the instruction, create a Python function that passes a JSON payload. The model returns a new, complete function. Which foundational generative AI capability is being used? The choices are: Option A, text classification. Option B, text summarization. Option C, text generation. Option D, text embedding generation. The correct choice is C, text generation. The key clue points here because the model creates new code from a natural language instruction. Code generation is a specialized form of text generation because source code is structured textual content produced by a generative model. A. Text classification assigns a predefined label to input text. B. Text summarization condenses existing content. D. A text embedding generation converts content into numerical vectors for similarity and retrieval tasks. Watch for this clue in similar questions. Generating source code from a natural language instruction is a generative text capability, commonly called code generation. Let's break down question number 117. Read the scenario with the target outcome in mind. An enterprise architecture team is evaluating multiple foundation models. While several models score highly on academic reasoning benchmarks, the team needs to determine which model will actually deliver the desired ROI for their specific customer support workflow. Which strategy best determines if a model meets the company's business objectives? Review the options and eliminate any clear mismatch. Choice A. Assess the model's alignment with specific business use cases. Choice B. Measure the computational resources required for model deployment. Choice C. Evaluate the model's performance purely on open-source benchmark datasets. Choice D. Analyze the model's underlying neural network architecture and hyperparameters. The best answer is A. Assess the model's alignment with specific business use cases. Here is the reasoning that confirms the answer. While technical metrics, accuracy, latency, are important, the ultimate measure of an AI model's success is whether it effectively solves the business problem and delivers ROI. A model that scores perfectly on academic benchmarks is useless if it does not align with the specific constraints, tone, and requirements of the company's real-world customer support use case. Check why each remaining option is not the best fit. B. Measuring computational resources dictates the operational cost, but a cheap model that fails to solve the business problem does not meet business objectives. C. Open-source benchmark datasets measure general academic reasoning. They do not reflect the nuanced, proprietary requirements of a company's specific business use case. D. The underlying architecture, for example, transformer versus RNN, is an implementation detail that matters to engineers, but it does not determine whether the model achieves the business outcome. Remember this decision rule. In the AI life cycle, technical metrics must always be mapped back to business objectives. Real-world use case alignment is the final arbiter of model success. Move to question number 118. Identify the requirement in this scenario. A research team has a dataset consisting of 100,000 images. Every image has already been manually tagged with the correct animal species it contains. The team wants to train a model to predict the species of new animal images. Which machine learning paradigm should the team use? Review the options. Choice A, reinforcement learning. Choice B, unsupervised learning. Choice C, supervised learning. Choice D, active learning. The required response is C, supervised learning. The requirement to solution matches supervised learning trains a model from examples that contain both input features and known target labels. Because every image already has the correct animal species label, the model can learn to classify new images from these labeled examples. The incorrect choices are plausible, but unsuitable because A. Reinforcement learning learns actions through rewards and penalties. B. Unsupervised learning finds patterns in data without target labels. D. Active learning is useful when a model selectively requests additional labels. The dataset in this scenario is already fully labeled. Exam strategy. When training data includes the correct target label for every example, use supervised learning. For question number 119. Separate the requirement from the distractors. Look for the wording that eliminates the distractors. A grocery delivery service trained a model to predict daily order volumes. Initially accurate, the model's predictions have drifted over the last 6 months due to changing consumer habits. The company wants to restore and continuously improve the model's predictive accuracy. Which approach meets these requirements? Watch for distractors that are valid services but wrong for this scenario. Next, option A, use Amazon SageMaker to retrain the model iteratively using the most recent data. Next, option B, use Amazon CloudWatch to manually analyze customer order logs. Next, option C, use Amazon Recognition to optimize the existing model parameters. Next, option D, use Amazon Personalize to iterate on historical out-of-date data. After elimination, select A, use Amazon SageMaker to retrain the model iteratively using the most recent data. When a model's accuracy degrades in production because the real-world environment has changed, concept drift or data drift, the standard machine learning solution is to retrain the model on the newest, most representative data. Amazon SageMaker provides the environment to automate and iterate this retraining process. Now eliminate the distractors. B. Manually analyzing logs in CloudWatch might provide business insights, but it does not actually update the machine learning model's weights to improve its predictive accuracy. C. Amazon Recognition is a computer vision service for analyzing images and video. It cannot optimize a tabular demand forecasting model. D. Iterating on historical out-of-date data is the exact opposite of what is needed. To fix drift, the model must be exposed to fresh, recent data. Use this elimination rule in the exam. The solution for data drift or model decay in production is to continuously monitor the model and retrain it iteratively with new, fresh data. Question number 120 contains an important exam distinction. The difficulty is medium. Avoid choosing by keyword alone. The key exam clue is contained in this scenario. A real estate startup built a custom machine learning model to estimate property values. The startup wants to deploy this model as a scalable API endpoint, but does not want to provision, manage, or patch any underlying servers or infrastructure. Which deployment strategy meets these requirements? Focus on which option satisfies the complete requirement. Now, examine choice A. Deploy the model on an Amazon Elastic Kubernetes service, Amazon EKS cluster. Now, examine choice B. Deploy the model by using an Amazon SageMaker serverless endpoint. Now, examine choice C. Deploy the model directly on an Amazon EC2 instance. Now, examine choice D. Deploy the model by using Amazon CloudFront with an Amazon S3 integration. The option that satisfies the complete requirement is B. Deploy the model by using an Amazon SageMaker serverless endpoint. This option satisfies the complete requirement because Amazon SageMaker serverless inference allows you to deploy machine learning models as API endpoints without provisioning or managing the underlying infrastructure. It automatically scales compute capacity in response to traffic and scales down to zero when idle, fulfilling the requirement to avoid server management. Here is how to rule out the alternatives. A. Deploying on Amazon EKS requires managing Kubernetes clusters, node groups, and container networking, which violates the requirement to not manage infrastructure. C. Deploying directly on an Amazon EC2 instance requires the startup to provision, patch, and manage the OS and instance scaling manually. D. Amazon CloudFront is a content delivery network, CDN, used for caching static web assets in edge locations. It cannot host or execute custom machine learning model containers. A useful exam pattern is this. If a SageMaker deployment requirement explicitly states without managing servers, no infrastructure management, or intermittent traffic, the answer is SageMaker serverless inference. Focus on the key wording in question number 121. This scenario tests whether you recognize the controlling constraint. An automotive factory aims to automate its quality assurance process by using artificial intelligence to analyze photographs of vehicle parts and identify any surface scratches or manufacturing anomalies. Which category of AI application is most appropriate for this task? The exam distinction is hidden in these choices. Option A, Natural Language Processing, NLP. Option B, Computer Vision. Option C, Recommendation Engines. Option D, Time Series Forecasting. The required response is B, Computer Vision. The decisive reason is computer vision is the field of AI that enables systems to derive meaningful information from digital images, videos, and other visual inputs. It is the appropriate technology for identifying physical defects like scratches in photographs. The remaining options fail one or more requirements because A. Natural Language Processing, NLP, is used for understanding and generating text or speech, not image analysis. C. Recommendation engines are used to suggest items, like movies or products, to users based on preferences. D. Time series forecasting is used to predict future numerical values based on historical timestamp data. Match visual inspection and image analysis tasks directly with computer vision capabilities. Question number 122. We are moving to Amazon SageMaker AI. A retail enterprise needs to build a machine learning model to estimate customer churn. The data science team wants an automated workflow that evaluates candidate algorithms, tunes hyperparameters, and produces a high-performing model with minimal manual configuration. Which AWS capability meets these requirements? Compare. Option A, Amazon Comprehend. Option B, Amazon Personalize. Option C, Amazon SageMaker Autopilot. Option D, Amazon Quick. The correct choice is C, Amazon SageMaker Autopilot. The key clue points here because Amazon SageMaker Autopilot automates key model development tasks for tabular classification and regression, including data analysis, candidate model generation, training, and hyperparameter tuning. This directly addresses the requirement for an automated churn model workflow. A. Amazon Comprehend provides managed natural language processing capabilities. It is not a general AutoML workflow for churn prediction. B. Amazon Personalize builds recommendation and user personalization systems. D. Amazon Quick provides business intelligence and generative analytics capabilities, not automated custom ML model development. Watch for this clue in similar questions. For automated building, training, and tuning of tabular ML models, look for Amazon SageMaker Autopilot. Let's analyze question number 123. Start by separating the facts from the requirement. A financial institution fine-tuned a large language model to assist with credit card application reviews. During compliance testing, auditors discover that applicants from some postcodes receive systematically higher approval recommendations because those areas were underrepresented in the fine-tuning data. Which approach is the most cost-effective way to mitigate this data-driven bias? Now compare the choices one requirement at a time. Option A is train a completely new foundation model from scratch using diverse global datasets. Option B is implement retrieval augmented generation, RAG, to dynamically filter model outputs. Option C is incorporate more diverse, representative training data and fine-tune the model again. Option D is use AWS Trusted Advisor to automatically detect and remove biased parameters. The best answer is C. Incorporate more diverse, representative training data and fine-tune the model again. Here is the reasoning that confirms the answer. The biased recommendations are linked to unrepresentative fine-tuning data. Improving representation in that dataset and fine-tuning again directly addresses the source of the learned disparity without the cost of training a foundation model from scratch. Check why each remaining option is not the best fit. A. Training a foundation model from scratch is substantially more expensive and unnecessary for this targeted correction. B. RAG supplies retrieved context at inference time but does not directly correct bias learned in model weights. D. AWS Trusted Advisor provides AWS best practice recommendations. It does not identify and remove biased model parameters. Remember this decision rule. When bias is caused by underrepresented training examples, improve the dataset and retrain or fine-tune the model, then evaluate fairness across relevant groups. Work through question number 124. Step by step. First, locate the key operational constraint. An organization uses Amazon Bedrock for several generative AI applications. The security team requires all Amazon Bedrock API activity to be recorded for audits. The audit logs must be protected from deletion, retained for 5 years, and moved to the lowest cost archival storage because they are rarely accessed. Which two configurations meet these requirements? Choose two. More than one answer may be correct, so evaluate every option. Use the scenario constraints to assess these choices. Choice A. Store the events only in Amazon CloudWatch logs. Choice B. Create an AWS Cloud trail that delivers Amazon Bedrock events to Amazon S3. Choice C. Keep all audit objects in the Amazon S3 standard storage class for 5 years. Choice D. Configure the Amazon S3 log bucket with object lock and a lifecycle transition to S3 Glacier Deep Archive. Choice E. Use AWS Audit Manager as the raw API log destination. After elimination, select B. Create an AWS Cloud trail that delivers Amazon Bedrock events to Amazon S3. D. Configure the Amazon S3 log bucket with object lock and a lifecycle transition to S3 Glacier Deep Archive. The requirement to solution match is AWS Cloud Trail records Amazon Bedrock API activity and can continuously deliver events to Amazon S3. S3 object lock protects retained objects from deletion, while an S3 lifecycle rule can transition rarely accessed logs to S3 Glacier Deep Archive for low-cost multi-year retention. The incorrect choices are plausible, but unsuitable because A. CloudWatch logs can support monitoring, but storing audit data only that does not satisfy the stated immutable, lowest-cost archival design. C. S3 standard is intended for frequently accessed data and costs more for long-term archives. E. AWS Audit Manager collects and maps compliance evidence. It is not the raw destination that records every Bedrock API event. Exam strategy. Use CloudTrail for AWS API auditing, S3 Object Lock for retention protection, and S3 Glacier storage classes for infrequently accessed long-term archives. Question number 125. Focus. Scenario. A streaming video platform wants to increase user engagement by providing customized content suggestions based on individual viewing history and preferences. Which fully managed AWS service is designed specifically to deliver individualized recommendations? Option A. Amazon Recognition. Option B. Amazon Personalize. Option C. Amazon Distract. Option D. Amazon Kandra. The option that satisfies the complete requirement is B. Amazon Personalize. Amazon Personalize is a fully managed AI service that allows developers to quickly build and deploy personalized recommendations and user segmentation based on the same machine learning technology used by Amazon.com. Now eliminate the distractors. A. Amazon Recognition is used for image and video analysis. C. Amazon Extract is used to extract text and data from scanned documents. D. Amazon Kandra is an intelligent enterprise search service, not a personalized user recommendation engine. Use this elimination rule in the exam. Any scenario asking for customized product, content, or search recommendations points to Amazon Personalize. Approach question number 126. By checking every constraint. This question moves us into data privacy. Pay attention to qualifiers such as least, most, and minimum. A national healthcare provider is training an AI model using electronic health records. Due to strict governmental healthcare regulations, the organization must ensure that patient data is physically stored and processed exclusively within the borders of their home country. Which data governance concept addresses this regulatory requirement? Compare the options by fit, not by familiarity. Consider option A. Data residency. Consider option B. Data enrichment. Consider option C. Data quality. Consider option D. Data lineage. The best answer is A. Data residency. This option satisfies the complete requirement because data residency refers to the legal or regulatory requirement that data must be stored and processed within a specific geographic location or national border. Here is how to rule out the alternatives. B. Data enrichment involves enhancing existing data by appending missing or supplementary information. C. Data quality refers to the accuracy, completeness, and reliability of data. D. Data lineage involves tracking data origins, movements, and transformations over time. A useful exam pattern is this. When a question mentions geographic boundaries, borders, or country-specific storage laws, the answer is data residency. Question number 127. Tests careful elimination. Identify the decisive constraint before considering the options. An operations team is deploying a suite of machine learning models to production on AWS. They need a robust, scalable service to track system metrics, such as CPU utilization, latency, and error rates for the model endpoints. Which AWS service should the team use to collect and monitor these operational metrics? Eliminate every option that violates even one requirement. Next, option A. AWS config. Next, option B. AWS CloudTrail. Next, option C. Amazon CloudWatch. Next, Option D. AWS Trusted Advisor. The required response is C. Amazon CloudWatch. The decisive reason is Amazon CloudWatch is the AWS monitoring and observability service. It is used to collect and track operational metrics like CPU utilization and latency for AWS resources, including machine learning endpoints deployed on SageMaker. The remaining options fail one or more requirements because A. AWS config tracks resource configuration changes over time, not real-time operational performance metrics. B. AWS CloudTrail logs API calls for auditing purposes. It does not monitor performance metrics like latency or CPU. D. AWS Trusted Advisor provides best practice recommendations, not real-time operational metric tracking. For operational performance monitoring and metrics collection, CPU, latency, errors, Amazon CloudWatch is the correct choice. Question number 128. The focus now shifts to model customization. Scenario. An organization maintains a proprietary foundation model for domain-specific language tasks. To help the model learn new industry terminology and changing language patterns, the machine learning team periodically updates its weights using large batches of recently collected, unlabeled domain text. Which model customization strategy is the team implementing? Compare the options. Option A. Continued pre-training. Option B. Zero-shot prompting. Option C. Retrieval augmented generation, RAG. Option D. Reinforcement learning from human feedback, RLHF. The correct choice is A. Continued pre-training. The key clue points here because continued pre-training extends a foundation model's pre-training by exposing it to additional unlabeled domain text. This updates the model weights so the model can learn domain-specific terminology, writing patterns, and relationships. B. Zero-shot prompting uses instructions without examples and does not update model weights. C. RAG retrieves external context during inference without changing the model's weights. D. RLHF aligns behavior with human preferences or feedback rather than primarily learning a large corpus of new domain text. Watch for this clue in similar questions. Continued pre-training uses large amounts of unlabeled domain text. Supervised fine-tuning generally uses labeled input-output examples. Start by identifying the requirement in question number 129. Review the scenario and identify what must be achieved. A developer is interacting with a large language model to solve complex logic puzzles. To improve the accuracy of the model's responses, the developer appends the instruction, explain your logic step by step before providing the final answer. Which prompt engineering technique is the developer applying? Check each option against the exact requirement. Option A is prompt injection. Option B is few-shot prompting. Option C is chain of thought prompting. Option D is directional stimulus prompting. After elimination, select C, chain of thought prompting. Here is the reasoning that confirms the answer. Chain of thought prompting involves guiding the model to break down a complex problem into a logical sequence of intermediate steps. Appending phrases like, explain your logic step by step, is the standard implementation of this technique. Check why each remaining option is not the best fit. A. Prompt injection is a security vulnerability where malicious input overrides the model's intended instructions. B. Few-shot prompting provides the model with multiple examples of inputs and desired outputs. D. Directional stimulus prompting provides a specific hint or keyword to guide the model's focus, not a step-by-step reasoning requirement. Remember this decision rule. Think step by step is the hallmark of chain of thought prompting. Question number 130. Find the decisive clue before choosing. Next, we enter the topic of Bedrock fundamentals. Identify the decisive constraint before considering the options. A startup wants to integrate generative AI capabilities into its software. The team prefers a fully managed environment that offers a choice of industry-leading foundation models, FMs, through unified APIs without managing the underlying infrastructure. Which AWS service provides these capabilities? Eliminate every option that violates even one requirement. Consider option A, Amazon Bedrock. Consider option B, Amazon Q Developer. Consider option C, Amazon SageMaker AI. Consider option D, Amazon Kandra. The option that satisfies the complete requirement is A, Amazon Bedrock. The requirement to solution matches. Amazon Bedrock is a fully managed service that provides access to foundation models from Amazon and leading model providers through managed inference APIs, allowing teams to build generative AI applications without managing model-serving infrastructure. The incorrect choices are plausible, but unsuitable because B, Amazon Q Developer is an AI assistant for software development and AWS tasks, not a general foundation model platform. C, Amazon SageMaker AI supports the broader ML lifecycle and custom model development, but Amazon Bedrock most directly provides managed access to multiple foundation models through unified APIs. D, Amazon Kandra is an enterprise search service. Exam strategy. Choose Amazon Bedrock for managed access to multiple foundation models. Choose Amazon SageMaker AI when the use case requires deeper control over custom ML development and deployment. Question number 131 is a good test of exam judgment. Focus on the requirement that drives the design choice. A software company is designing an accessibility tool for users with visual impairments. The application must accurately capture spoken commands from the user and reply with synthesized spoken audio. Which combination of underlying AI capabilities is required for this tool? Focus on which option satisfies the complete requirement. Option A, speech recognition and text-to-speech synthesis. Option B, image classification and semantic search. Option C, text summarization and sentiment analysis. Option D, anomaly detection and time series forecasting. The correct choice is A, speech recognition and text-to-speech synthesis. To capture spoken commands, the application needs automatic speech recognition, ASR. To reply with spoken audio, it requires text-to-speech, TTS, synthesis. These two AI capabilities directly fulfill the accessibility requirements. Now eliminate the distractors. B, image classification and semantic search deal with vision and text, not audio interfaces. C, text summarization and sentiment analysis process existing text but do not provide the required audio inputs and outputs. D, anomaly detection and time series forecasting are numerical analysis techniques unrelated to voice interfaces. Use this elimination rule in the exam. Voice applications require speech recognition, speech to text, to listen and text to speech to talk. Question number 132 is a good test of exam judgment. We are moving to prompt engineering. This scenario tests whether you recognize the controlling constraint. A data scientist is designing prompts for an AI assistant intended to solve complex mathematical word problems. The model often arrives at the wrong final number if it attempts to answer immediately. Which technique should the data scientist use to encourage the model to output its intermediate reasoning steps, thereby improving final accuracy? The exam distinction is hidden in these choices. Now examine choice A, zero-shot prompting. Now examine choice B. Few shot prompting. Now examine choice C. Chain of thought prompting. Now examine choice D. Negative prompting. The best answer is C. Chain of thought prompting. This option satisfies the complete requirement because chain of thought prompting forces the language model to articulate its reasoning process before delivering a final answer, which significantly improves performance on complex, multi-step logical and mathematical problems. Here is how to rule out the alternatives. A. Zero-shot prompting provides no examples or structural guidance, which often leads to poor performance on complex tasks. B. Few-shot prompting provides examples but does not inherently enforce a step-by-step reasoning process unless combined with chain of thought. D. Negative prompting tells the model what to avoid. For example, do not use jargon. It does not encourage logical reasoning steps. A useful exam pattern is this. When a model struggles with complex multi-step reasoning, use chain of thought prompting. Next is question number 133. Review the scenario. A data science team is categorizing various machine learning tasks to assign them to appropriate specialists. Select the correct machine learning paradigm for each described task type. Use the context of each statement to select its drop-down value. Statement 1. Identify the clue in. A task that predicts whether an email is spam or not spam is an example of the blank. Choose the stronger fit from 1. Supervised learning, unsupervised learning, or reinforcement learning. Statement 2. Identify the clue in. A task that categorizes an image into one of 10 different animal species is an example of the blank. Choose the stronger fit from 2. Supervised learning, unsupervised learning, or reinforcement learning. Statement 3. Identify the clue in. A task that groups customers based on purchasing behavior without predefined categories is an example of the blank. Choose the stronger fit from 3. Supervised learning, unsupervised learning, or reinforcement learning. Statement 4. Identify the clue in. A task that simplifies a dataset by reducing the number of variables while retaining important information is an example of the blank. Choose the stronger fit from 4. Supervised learning, unsupervised learning, or reinforcement learning. Question type, drop down. The correct answer is 1. Supervised learning. 2. Supervised learning. 3. Unsupervised learning. 4. Unsupervised learning. Here is why this answer is correct. Binary and multiclass classification learn from labeled examples, so they are supervised learning tasks. Clustering and dimensionality reduction identify structure in unlabeled data, so they are unsupervised learning tasks. Answer rows. 1. A task that predicts whether an email is spam or not spam is an example of select. Vertical bar supervised learning. Vertical bar binary classification is trained with labeled spam and non-spam examples. 2. A task that categorizes an image into one of 10 different animal species is an example of select. Vertical bar supervised learning. Vertical bar multiclass classification is trained with labeled species examples. 3. A task that groups customers based on purchasing behavior without predefined categories is an example of select. Vertical bar unsupervised learning. Vertical bar clustering discovers natural groups in unlabeled data. 4. A task that simplifies a dataset by reducing the number of variables while retaining important information is an example of select. Vertical bar unsupervised learning. Vertical bar dimensionality reduction identifies lower dimensional structure without target labels. Here is an important exam tip. Classification and regression are supervised, clustering and dimensionality reduction are generally unsupervised. Now tackle question number 134. The focus now shifts to AI governance. Identify the requirement in this scenario. A large enterprise is establishing an AI center of excellence to ensure their machine learning initiatives are deployed safely and maintain stakeholder trust. Which activity is a core component of an AI governance framework? Choice A. Establishing policies, guardrails, and compliance standards for responsible AI use. Choice B. Expanding AI compute clusters to maximize total operational throughput. Choice C. Replacing human oversight entirely with automated model decision-making. Choice D. Optimizing cloud infrastructure costs for foundation model inference. The required response is A. Establishing policies, guardrails, and compliance standards for responsible AI use. The decisive reason is AI governance is the framework of rules, practices, and processes that ensure AI technologies are developed and used in ways that are safe, responsible, compliant with regulations, and aligned with organizational values. The remaining options fail one or more requirements because B. Expanding compute clusters is an IT operations or infrastructure scaling activity, not governance. C. Replacing human oversight contradicts responsible AI governance, which often mandates human-in-the-loop processes for critical decisions. D. Optimizing cloud infrastructure costs is part of financial management, FinOps, not AI governance. AI governance focuses on policies, risk management, compliance, and responsible AI guardrails. Let's break down question number 135. Read the scenario with the target outcome in mind. A marketing agency has a large dataset of customer interaction metrics and transaction histories. The data contains no predefined labels or categories. The agency wants to discover natural groupings of customers to tailor future advertising campaigns. Which algorithm is appropriate for discovering these groupings? Use the scenario constraints to assess these choices. Option A is random forest. Option B is k-means. Option C is linear regression. Option D is k-nearest neighbors, KNN. The option that satisfies the complete requirement is B, k-means. The key clue points here because k-means is an unsupervised machine learning algorithm used for clustering. It is ideal for identifying natural groupings or segments within unlabeled data, such as customer purchasing behavior. A. Random forest is a supervised learning algorithm used for classification and regression on labeled data. C. Linear regression is a supervised learning algorithm used to predict continuous numerical values. D. K-nearest neighbors, KNN, is typically a supervised learning algorithm for classification, requiring labeled data. Watch for this clue in similar questions. When tasked with finding groups or segments in unlabeled data, look for clustering algorithms like k-means. Start by identifying the requirement in question number 136. Next, we enter the topic of inference parameters. Start by separating the facts from the requirement. A developer uses a large language model to summarize internal documents. Repeated runs of the same prompt produce overly varied and creative wording. The developer wants the responses to be more consistent and less random. Which inference parameter adjustment can help achieve this goal? Check each option against the exact requirement. Choice A. Increase the top p-value. Choice B. Decrease the temperature parameter. Choice C. Increase the maximum token length. Choice D. Decrease the number of attention heads. After elimination, select B. Decrease the temperature parameter. Here is the reasoning that confirms the answer. Temperature controls output randomness. Lowering it makes the model favor higher probability tokens, which generally produces more consistent and less varied responses. This does not guarantee factual accuracy or eliminate hallucinations. Check why each remaining option is not the best fit. A. Increasing TOPI broadens the candidate token pool and can increase variation. C. Maximum token length controls how long the response can be, not how random it is. D. The number of attention heads is part of the trained model architecture and is not a normal inference time control. Remember this decision rule. Lower temperature generally increases consistency. Grounding, RAG, source checks, or validation are still needed to address factual accuracy. Next, question number 137. Scenario. A development team is using a base foundation model through the Amazon Bedrock Converse API to create a multi-turn assistant. Because each model invocation needs the relevant conversational context, the assistant must preserve details from earlier turns. How should the application provide that context to the model? Options. Option A. Enable an automatic memory toggle in the AWS Management Console. Option B. Include the relevant prior messages in each Converse request. Option C. Increase the model's temperature setting to improve memory recall. Option D. Fine-tune the model after every user interaction. After elimination, select B. Include the relevant prior messages in each Converse request. The requirement to solution match is a conversational application supplies the relevant message history when it calls the Converse API. The application can maintain that history itself or retrieve it from session storage, but the model needs the prior messages as input context for the current turn. The incorrect choices are plausible, but unsuitable because A. Base model conversation context is not created by a simple console memory toggle. C. Temperature changes output randomness, not conversation memory. D. Fine-tuning after every interaction is impractical and does not provide short-term session context. Exam strategy. For stateless model inference, preserve conversation history outside the model and include the relevant messages in later requests. Work through question number 138. Step by step. This question moves us into Bedrock fundamentals. Review the scenario and identify what must be achieved. A media company wants to generate personalized daily news summaries for its subscribers based on their regional interests. They plan to use state-of-the-art foundation models to automate the generation of this text. Which AWS service is designed to provide access to foundation models for building this generative AI solution? Review the options and eliminate any clear mismatch. Choice A. Amazon Textract. Choice B. Amazon Macy. Choice C. Amazon Bedrock. Choice D. Amazon Transcribe. The correct choice is C. Amazon Bedrock. Amazon Bedrock is the AWS service designed to build and scale generative AI applications using foundation models. It provides the capabilities needed to automate text generation tasks like personalized news summaries. Now eliminate the distractors. A. Amazon Textract extracts text and data from scanned documents. It does not generate new text. B. Amazon Macy is a data security service that discovers sensitive data in Amazon S3. D. Amazon Transcribe converts speech to text. It does not generate summaries from scratch. Use this elimination rule in the exam. For generative AI tasks using foundation models, like text generation or summarization, Amazon Bedrock is the primary managed service. For question number 139. Separate the requirement from the distractors. Look for the wording that eliminates the distractors. A financial services firm stores millions of historical support transcripts in Amazon S3. Before using this data to train machine learning models, the firm needs an automated way to discover and alert on sensitive personal information, such as credit card numbers and social security numbers, with minimal operational overhead. Which solution requires the least development effort to meet this requirement? Watch for distractors that are valid services but wrong for this scenario. Consider option A. Deploy an open-source large language model on Amazon EC2 to scan the text. Consider option B. Configure Amazon MEC to run sensitive data discovery jobs on the S3 buckets. Consider option C. Write custom Python scripts using regular expressions and run them in AWS Lambda. Consider option D. Use Amazon Comprehend custom entity recognition and train a new model. The best answer is B. Configure Amazon MEC to run sensitive data discovery jobs on the S3 buckets. This option satisfies the complete requirement because Amazon MEC is a fully managed data security and data privacy service that uses machine learning and pattern matching to automatically discover and protect sensitive data, like PII, in Amazon S3 with minimal configuration and no custom development required. Here is how to rule out the alternatives. A. Deploying an open-source LLM on EC2 requires significant infrastructure management and development effort. C. Writing custom Lambda scripts requires manual development, maintenance of regular expressions, and does not scale as effortlessly as a managed service. D. Amazon Comprehend custom entity recognition requires preparing labeled training data and training a model, requiring much more effort than using MEC. A useful exam pattern is this. For automated, low-effort discovery of sensitive data, PII, residing in Amazon S3, Amazon MEC is the correct choice. Question number 140. This question moves us into cost and performance. Review the scenario. A telecommunications company has deployed a generative AI virtual agent to handle first-line support queries. Leadership wants to evaluate the direct monetary impact of this new AI deployment compared to the traditional call center model. Which metric provides the best insight into the financial efficiency of the AI agent? Review the options. Choice A. Cost per customer conversation. Choice B. Average model inference latency. Choice C. Total number of training tokens. Choice D. Model precision and recall scores. The required response is A. Cost per customer conversation. The decisive reason is to measure the financial effect of the generative AI chatbot on operations. The business must evaluate the cost to resolve a single customer query using AI compared to human agents. Cost per customer conversation directly reflects this financial impact. The remaining options fail one or more requirements because B. Average model inference latency measures technical performance, not direct financial impact. C. Total number of training tokens relates to upfront training costs but does not measure the ongoing operational financial efficiency of the deployed agent. D. Model precision and recall scores evaluate algorithmic accuracy, not financial return on investment. Always align the chosen metric with the specific business goal. Financial impact requires financial metrics, like cost per interaction, not technical metrics. Move to question number 141. A data science team is initiating a new machine learning project to predict supply chain shortages. They must follow standard ML lifecycle practices. Select the correct sequence of high-level steps for an ML workload. Treat each blank as a separate decision and choose the best fit. For the first statement, evaluate. The first step in the ML lifecycle is to the blank. The candidates are 1. Define the business goal, develop the model, deploy the model, or monitor the model. For the second statement, evaluate, the second step is to the blank. The candidates are to define the business goal, develop the model, deploy the model, or monitor the model. For the third statement, evaluate, the third step is to the blank. The candidates are 3. Define the business goal, develop the model, deploy the model, or monitor the model. For the fourth statement, evaluate, the final step of the life cycle loop is to the blank. The candidates are 4. Define the business goal, develop the model, deploy the model, or monitor the model. Question type, drop down. The correct answer is 1. Define the business goal. 2. Develop the model. 3. Deploy the model. 4. Monitor the model. Here is why this answer is correct. An ML workload begins by defining the business problem and success criteria. The team then prepares data and develops and evaluates the model, deploys the selected model, and monitors production performance and drift to guide future iterations. Answer rows. 1. The first step in the ML life cycle is to select. Vertical bar define the business goal. Vertical bar business requirements and success criteria guide the ML approach. 2. The second step is to select. Vertical bar develop the model. Vertical bar this high-level phase includes data preparation, training, and evaluation. 3. The third step is to select. Vertical bar deploy the model. Vertical bar the validated model is integrated into a production environment. 4. The final step of the life cycle loop is to select. Vertical bar monitor the model. Vertical bar production monitoring identifies degradation and informs retraining or other improvements. Here is an important exam tip. At a high level, define the goal, develop and evaluate, deploy, then monitor and iterate. Next is question number 142. Scenario. An IT department is providing internal applications with access to foundation models through Amazon Bedrock. The team must choose an inference mode based on latency and workload volume. Select the correct Amazon Bedrock inference mode for each scenario. Solve the blanks one at a time. Do not carry assumptions between them. Now solve statement 1. A live customer service chatbot requires an immediate response to each user message. This requires the blank. Eliminate between 1. On-demand inference or batch inference. Now solve statement 2. A nightly job processes thousands of documents asynchronously and writes the results to Amazon S3. This requires the blank. Eliminate between 2. On-demand inference or batch inference. Now solve statement 3. A low-latency mobile service processes individual text snippets as requests arrive. This requires the blank. Eliminate between 3. On-demand inference or batch inference. Question type, drop down. The correct answer is 1. On-demand inference. 2. Batch inference. 3. On-demand inference. Here is why this answer is correct. Amazon Bedrock on-demand inference supports individual interactive requests, making it suitable for chatbots and low-latency services. Batch inference processes many prompts asynchronously and writes results to Amazon S3, making it suitable for large offline jobs. Answer rows. 1. A live customer service chatbot requires an immediate response to each user message. This requires select. Vertical bar on-demand inference. Vertical bar interactive chat requires individual synchronous model invocations. 2. A nightly job processes thousands of documents asynchronously and writes the results to Amazon S3. This requires select. Vertical bar batch inference. Vertical bar batch inference processes many requests asynchronously and stores the output in Amazon S3. 3. A low-latency mobile service processes individual text snippets as requests arrive. This requires select. Vertical bar on-demand inference. Vertical bar requests that arrive individually and need prompt responses use on-demand inference. Here is an important exam tip. Use on-demand inference for interactive requests and batch inference for high-volume asynchronous processing. Approach question number 143. By checking every constraint. Pay attention to qualifiers such as least, most, and minimum. A team of AI practitioners is sharing templates for interacting with a large language model. Select the correct prompt engineering technique for each template. Complete every statement by matching the requirement to the option. The first blank appears in analyze the following text and determine if the sentiment is positive, negative, or neutral. Input text is an example of the blank. Compare 1. Zero-shot prompting, few-shot prompting, or chain-of-thought prompting against the requirement. The second blank appears in here are 3 examples of well-written product descriptions. Based on these, write a description for new product is an example of the blank. Compare to zero-shot prompting, few-shot prompting, or chain-of-thought prompting against the requirement. The third blank appears in solve this logic problem. Explain your reasoning step by step before providing the final answer is an example of the blank. Compare 3. Zero-shot prompting, few-shot prompting, or chain-of-thought prompting against the requirement. Question type, drop-down. The correct answer is 1. Zero-shot prompting. 2. Few-shot prompting. 3. Chain-of-thought prompting. Here is why this answer is correct. A task instruction without examples is zero-shot prompting. Supplying several examples is few-shot prompting. Requesting explicit intermediate reasoning is chain-of-thought prompting. Answer rows. 1. Analyze the following text and determine if the sentiment is positive, negative, or neutral. Input text is an example of select. Vertical bar zero-shot prompting. Vertical bar the prompt provides the task and labels but no worked examples. 2. Here are 3 examples of well-written product descriptions. Based on these, write a description for new product is an example of select. Vertical bar few-shot prompting. Vertical bar the prompt includes several examples to guide the new output. 3. Solve this logic problem. Explain your reasoning step by step before providing the final answer is an example of select. Vertical bar chain-of-thought prompting. Vertical bar the prompt asks for intermediate reasoning before the answer. Here is an important exam tip. Zero-shot means no examples, few-shot means a small set of examples, and chain-of-thought requests intermediate reasoning. You have completed part 5 of the AIF-C01 exam practice series. Continue your preparation by opening the complete playlist and watching the remaining parts in sequence. Please like this video, subscribe to Tech with Kaushik, and enable notifications for more certification exam preparation content. Share your score, questions, or feedback in the comments. Thank you for watching. See you in the next part.